We really need to do something about this object because we just got probably the clearest 3-eye atlas images yet, and the details coming out of these observations are once again breaking some fundamental rules of comet physics. Also, Harvard astrophysicist Avi Loeb just published a new analysis, and he's revealing some more weird stuff that science can't seem to explain. We're seeing tail structures that probably shouldn't exist at this distance from the Sun. We're measuring brightness levels that contradict every prediction. And the geometry of what is happening is revealing significant problems with the standard heat physics model. So, in this video, I'll explain what is actually happening with 3-eye atlas and why it's also weird to be happening. Right now, 3-eye atlas is sitting at about 186 million miles from Earth. That is exactly twice the distance between Earth and the Sun. Before we talk about the mass loss and brightness problems, let's talk about something in these images that is breaking the fundamental physics of how comets are supposed to work. This recent image was captured by an amateur astronomer on November 22nd using a half-meter telescope, which is a telescope that collects significantly more light than smaller telescopes, allowing it to see fainter and more distant objects. The image shows a bright glowing coma around the nucleus, with two distinct structures extending outward. These structures are the comet's tails. This tail stretches away from the Sun for about 3 million miles, and the other tail, which points toward the Sun, is about 600,000 miles long. Both tails are remarkably narrow and focused. This image is from November 24th, even though the object is only 15 degrees above the horizon, which makes it very hard to observe. The same basic structures appeared. Multiple independent observers are seeing the same thing, which confirms these are real features and not imaging artifacts. What's strange here is how tight these jets appear. Normal comet tails spread out and get fuzzy as they extend into space. These are staying collimated like laser beams across millions of miles. So why is one tail 5 times longer than the other? Well, the normal away-from-sun tail has help. Solar radiation pressure and the solar wind are both pushing in that direction. But the toward-sun tail has to fight against those same forces. Every particle in that anti-tail is pushing directly into the solar wind, kind of like swimming against the waves. To create a 600,000-mile-long tail fighting against the solar wind, the material has to be incredibly dense. Loeb calculated that the mass density in the anti-tail needs to be about 1 million times greater than the density of the solar wind itself. That is not typical comet outgassing density, that is something else entirely. And this 5:1 ratio is not changing. Earlier images showed the same proportions. Whatever mechanism is creating these jets, it is maintaining consistent physics across hundreds of millions of miles through space. We have never seen a comet maintain this kind of stable asymmetric jet structure for this long. Usually, comet activity fluctuates wildly as different ice deposits get exposed to sunlight during rotation. But 3-eye atlas is once again breaking the rules of physics. Now, before we talk about the brightness anomaly here, let's first talk about the mass loss problem. These tails are made of stuff evaporating from the comet due to the Sun's heat. This process is called sublimation. At 186 million miles from the Sun, the surface of 3-eye atlas should be extremely cold. The Sun puts out a certain amount of energy per square meter at any given distance. For perspective, the Sun delivers more energy to Earth in 1 hour than all of humanity uses in an entire year. At Earth's distance, that energy is about 1,300 watts per square meter. At 180 million miles, that drops to roughly 300 watts per square meter. That is the total solar energy hitting the surface. But here's the key detail about comets. Not all of that energy goes into heating ice. Much of it reflects off the surface, and much of it radiates back out as infrared heat. Only a fraction actually goes into sublimating ice from solid directly to gas. For carbon dioxide ice, which is the main volatile on 3-eye atlas, the sublimation temperature is around 78 degrees Celsius. At the solar energy levels present at 186 million miles, you can calculate exactly how much ice should be sublimating per square meter per second. Well, Avi Loeb did the calculation, and to produce the mass loss rate we are observing in these November images, you would need about 620 square miles of active surface area, all sublimating at maximum efficiency. But NASA just released an image from the Mars Reconnaissance orbiter captured in early October showing 3I Atlas as a soft, glowing white ball. The image shows the cloud of dust and gas around it measuring approximately 932 miles in diameter. But the actual solid material doing the sublimating is way smaller. Based on earlier measurements, the nucleus is only a few miles wide, which gives it maybe 30 to 40 square miles of total surface area. Even if we assume the solid nucleus inside takes up a significant portion of that coma, the actual icy surface doing the sublimating is far smaller than the 620 square miles needed to explain the mass loss. Image comparison of the nucleus size versus the required active surface area for sublimation. The math does not work. You cannot get this much material from heat-driven ice sublimation with the available surface area. Science says that this would make sense if the object has broken into fragments, which often happens as comets hit their closest point to the Sun. More fragments means more total surface area, but images from November 11th showed one single intact nucleus. No fragments, no debris cloud, just one solid body. Okay, so the surface area does not add up. But the most recent images reveal yet another strange anomaly. 3I Atlas is way brighter than it should be at this distance after passing the Sun. Comets follow predictable brightness curves. As they approach the Sun, they heat up and get brighter. After passing perihelion, they move away from the Sun and cool down. The brightness drops off in a predictable way based on distance. 3I Atlas has been moving away for over a month now. At 180 million miles distance, the solar heating has dropped significantly. Activity should be declining and therefore the brightness should be fading. But the November images show strong sustained brightness. The coma is still glowing intensely, the tail structures are still prominent and well-defined. There is no sign of the expected dimming. Harvard scientist Avi Loeb calculated that to maintain this brightness level, the object has to be losing about 200 tons of material per second. That is an enormous ongoing mass loss rate for an object that should be cooling down and quieting down. If 3I Atlas has been losing 200 tons per second since perihelion, that adds up to billions of tons of total mass lost. For an object estimated at 33 billion tons, this represents roughly 10% of its entire mass shed in just 2 months. A natural comet losing that much mass that quickly should show dramatic changes. The nucleus should be shrinking visibly, and the activity should be sputtering and fluctuating as internal structure fails. But none of those things are happening. We are witnessing an object that maintains a laser-like jet structure and a massive mass loss rate far beyond what its size or the solar energy levels should allow. Whether it's an exotic natural object or something more unusual, the standard models are clearly being pushed to their limits. Let me know your thoughts and theories in the comments. And please drop me a like and hype if you appreciate my effort. I Atlas.